In this video, we're going to learn how to draw a graph of an equation that's already written in polar coordinates. These are called polar equations. Now, sometimes you could just take your equation, convert it to x and y, and then graph it. And if so, feel free to do that. This first example here, if you wanted to, you could multiply both sides by r, and then convert to x and y with x squared plus y squared is 2y, and you can go ahead and solve that out. But it's not always going to work. For example, the second one down here, this one is not going to convert nicely into x and y. And it's better to learn how to draw any graph with r and theta, so it doesn't matter if you can convert to x and y, you can still draw out the solution. Well, what we're going to do is we're going to remember when you were drawing sines and cosines before, you went every pi over 2, and we had that 5-point method for drawing sines and cosines. And so we're going to do the same idea. We're going to break it up every pi over 2 here, and we're going to make ourselves a little table. Sorry, we're going to generally put theta first here. And we're going to say theta starts out 0 and goes to pi over 2. What happens to r? When we go from pi over 2 to pi, what happens to r? When we go from pi to 3 pi over 2, what happens to r? And when we have 3 pi over 2 to 2 pi, what happens to r? So we're going to use the formula we're given, 2 sine theta. So when we go ahead and plug in 0 to that, we get r is 0. When we plug in pi over 2, we're going to get to 2 here. So that means that when we're facing the 0 angle, we're starting at 0. And then by the time we're facing the pi over 2 angle straight up, we're supposed to be an r of 2. So that means it's going to go out to here. So it's going to come out and get up to the higher angle. So every time we increase our angle, we're getting further away from the origin until we get to 2 there. Then we go from pi over 2 to pi over 2 to pi. So sine of pi over 2 is 1, there's 2 there, and then sine of pi is 0. So that means by the time we get from pi over 2 to pi, when we get back into this direction over here, then we're going to be back at the origin. Then when we plug in pi, we get 0 to 3 pi over 2 is negative 1. We're going to be at negative 2. So that means when we are going downwards, we have a negative r. So negative r's always just go the opposite direction. So as I increase down here, I would get further away from the origin, except it's supposed to be going in the opposite direction because it's a negative r. And so what's going to end up happening is you're going to trace this part of the graph here a second time. And when you do this here, negative 2 back to 0, it's going to end up tracing the other side. So in this particular example, we end up going around the circle twice as we go from 0 to pi. And you won't know ahead of time if that's going to happen or not. Sometimes you're only going to trace around the shape a single time. Sometimes you're going to trace around twice, sometimes trace around 3 times. It just depends on the specific equation you have. Now, let's take that same process and apply it to the second equation, which I think is harder. So we're going to break up our theta here and our r. Same 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi. Plug in our r's here. So when theta is 0, cosine 0 is 1, 1 plus 1 is 2. Then when we go to cosine pi over 2, that's 0, 0 plus 1 is 1. And if I just kind of quickly plug in numbers here, I'm going to get this. And if I try to draw this, it says when we're starting in the 0 angle, we're supposed to go out 2. So that's at 2 here. Then by the time we get up to the angle pi over 2, we're supposed to be only 1 away. So it's going to get closer in like this. And then by the time we get to pi, it's supposed to be to 0. And then as we go down to 3 pi over 2, it goes back out to being 1. And then finally, it goes back out to 2 as we get to 2 pi. And if I try to draw it maybe a little nicer here, it looks something like this. And if you turn that on its side, it looks like a heart. And that is why we call this shape a cardioid. So graphing polar equations is probably the most challenging thing we do in this whole class, in my personal opinion. I wouldn't worry too much about it right now because we're just kind of barely introducing this at the very end. See a couple examples here. But as I said, you're not going to see this again for a year-ish, and then you're going to have to kind of relearn it at that point anyways. So we're just trying to introduce it to you now so that later when you have to use it for problems, it's not completely brand new. It's more reviewing rather than learning from scratch. So this table method of drawing these polar equations is, in my opinion, the best way to do it. And if you have any questions, let me know.